All right, so today I want to talk to you about two incredibly important types of energy that affect your daily life: electricity and magnetism. We're going to be very careful today to describe these two, what they are, how they work, and we're going to do that by looking at several different experiments and then trying to piece it all together. So, as we're going through this, just remember our guiding question right now is this. We know that electricity and magnetism are types of energy. Remember, the main definition of energy is the ability to cause a change in a system. Electricity is definitely able to do that. You flip on a light switch, some kind of change happens, and now there's lights in the room. You plug in your phone, charge it into the wall, some sort of change happens, and now your phone has more electrical energy. So, electricity is able to cause a change, magnetism is able to cause a change in systems. So, we can think about these two phenomena as types of energy. But we want to describe them and explain them. So, what are they? What causes them? Where do they come from? What gives rise to them? And then we're going to try to figure out if they're related to each other. So, do they have any sort of relationship? And we're going to do this through several different experiments. So, experiment number one, basically imagine I give you a battery, some wires, a switch, a light bulb, and I give you the task of using the battery to power the light bulb. How can we arrange these pieces to get electricity to flow? And I think all of you would be able to do this pretty quickly. You would probably know right away that you need the wires connected to both parts of the battery, um, a wire flowing from the battery to the switch, from the switch to the light bulb, and then back to the battery. That's incredibly important. You'll notice that the whole system kind of makes a circle, it makes a closed loop. When the switch is open, I have no electricity flowing. My light bulb is not lit. As soon as I close the switch, now you can see I have one complete closed loop and the light bulb is indeed lit. If you were to break off this red wire right here, electricity would stop flowing. If you were to break off this wire or this one, electricity would stop flowing. So the key idea here is that in order to have electricity, in order to be able to cause a change in the system using electricity, we have got to have a source of power, the battery. Obviously, if the battery was not there, this would not work. Pretty common sense. And we have to have a system that is arranged in a closed loop. So electricity has got to flow like this in a circle. So that's something to keep in mind. This is our conclusion for this experiment. Our second experiment is just going to be about magnets, magnetism. What are some properties of magnets? These things you guys probably know already. If I give you some magnets and some compasses to play with, you would probably notice, first of all, that a magnet is capable of changing compass needles, which way the compass needles point, how the compass needles deflect. So magnets are able to affect the needles of a compass, and they're able to do that over a distance. Notice that these compasses right here are not even touching the magnet, and yet their compass needles are still deflected. So very, very interesting. Magnets are able to cause a change over a distance. If you were to be playing with several magnets, you would probably feel a difference based on how the magnets are oriented toward each other. You know that opposites attract. The South Pole and the North Pole would be attracted to each other. They would want to stick together. Whereas South and South or North and North would want to repel. You would not be able to touch those together. And then finally, imagine that I give you some little tiny pieces of iron metal called iron filings, and you kind of sprinkle those around the magnet. And here you can really see very, very clearly how the magnet seems to cause a change over a distance. Way out here, where the magnet is not even touching these iron filings, the iron filings have somehow almost magically kind of aligned themselves in a certain arrangement. That's incredibly interesting that would happen. So, all of this in mind, we might say this. Magnets are able to exert a force over a distance. They're capable of acting over a distance, affecting other magnets, compass needles, and some metals, like the iron filings. This force at a distance and the potential to cause a change seems to radiate out from the magnet as a field. So this iron filing uh, example over here, what we're really seeing is what we call a magnetic field, this sort of potential to cause a change radiating outward from the magnet. which is kind of amazing if you think about it, that it's able to act over a distance in this organized way like this. Here's a little visual of a magnet with the south and north pole. And what you see here, these little diamond shapes, are just representing the magnetic field. So you can see that as I move the magnet through space, the magnetic field is changing. And you'll notice that this compass over here is changing as well. So if I move the compass, you'll see the needle line up with the magnetic field. So we know something about electricity, we know something about magnetism. Now let's get a little bit more complex. Let's start asking the question, are they related to each other? Can electricity cause magnetic effects? Can electricity give rise to a magnetic field, maybe? So think about this experiment. Here we have a battery, a source of power. And then connected to that battery, we have what are known as alligator clips, just wires, basically. And then we have another wire that's running through this cup. On top of the cup, we have an index card, and we've set a compass right here, pretty close to this wire. You'll notice that this is a closed loop of wire. So remember, whenever we have a power source and a closed loop, we know that electricity is going to flow. In fact, if we were to put a light bulb in here, we'd see the light bulb light up. So we know there's electricity flowing. What do you think we're going to see happen to this compass? Well, believe it or not, the compass needle will actually move. It will be deflected depending on how we move the compass around the outside of this wire. There is electricity flowing through this wire, and the compass needle is going to change. That's kind of amazing. What can we conclude from this? Well, what was the only thing that was capable of causing the compass needle to change earlier? A magnet, right? So now if we see flowing electricity causing that exact same change, we must conclude this. Flowing electricity must be giving rise to a magnetic field. Electricity flowing through a wire is able to turn a compass needle, just like a magnet. So flowing electricity must give rise to a magnetic field. That's interesting. We should be thinking, maybe electricity and magnetism are somehow related to each other. Let's do a similar experiment now to ask the same question in a different way. So experiment 3B. Same question, can electricity cause magnetic effects? So let's say that I give you a battery, some wire, and a nail. And you wrap the wire many times, tightly coiled around the nail, and you connect it to both ends of the battery. So do we have electricity flowing here? Yes, we do. Remember, electricity requires some sort of power source and a closed loop. So this is definitely a closed loop. And what we will notice is that if we have set up our system correctly and carefully, if we have coiled this wire tightly around the nail, you can do this very easily at home, we will notice that the nail begins to act like a magnet. So once again, we have seen that electricity can give rise to a magnetic field. Electricity is giving rise to magnetic effects. Electricity flowing through coils of wire is able to attract metals, just like a magnet can. Therefore, we know that flowing electricity must be giving rise to a magnetic field. So these two experiments, the straight wire deflecting the compass needle and the coiled wire causing the nail to act like a magnet, from these two experiments we can conclude that, yeah, electricity is capable of causing magnetic effects. Electricity can give rise to magnetism. So that's incredibly interesting. Let's ask the opposite question now. Can magnets generate electricity? Can we cause electricity to flow using magnets somehow?